Welcome to Multiple Choice Monday number 7. So the correct answer for which one of these is polar was B, NH3. So you might have worked it out through a bit of logic and a dot and cross diagram. You might have had a lucky guess or remembered that ammonia has hydrogen bonding and therefore must have some sort of dipole. So I'm just going to show you a couple of quick techniques for deciding whether a molecule has an overall dipole or not. There are two questions that we need to have to ask ourselves. First of all, are there any polar bonds? Now you probably learned lots and lots and lots about electronegativity, but it can basically boil down to a couple of very simple rules. If there are different elements, any elements that are not the same as each other and that are not carbon and hydrogen. So basically any molecule that is not a hydrocarbon, so alkanes, alkenes, benzene rings, you can pretty much always assume that there will be a polar bond. That doesn't help us very much with this question because every single one of these molecules has got polar bonds in it. So we've got differences in electronegativities between all of these different types of atom. So the next thing we need to look at is whether or not those polar bonds, those delta plus, delta minuses, are cancelled out by the symmetry of the molecule. Now we could sit and think a long time about, well, what shape is that molecule? Does it have symmetry? But actually the easiest thing to look at is, does the molecule or does the central atom have one or more lone pairs? Because if you think about it, bonds are made up of electrons that are being shared, lone pairs are pairs of electrons too. And we know that the shape of the molecule comes from those pairs of electrons spreading out as far apart as possible. So if there is at least one lone pair in the molecule, it means that the bonds, which are polar, because we've established that every single one of these molecules has got polar bonds in it, they will be spread symmetrically if there are no lone pairs, because they'll get as far apart as they possibly can, and they'll be spread asymmetrically if there are lone pairs. So how do we decide whether something has lone pairs or not? Do we have to sit and draw the dot and cross diagrams? Well, we can, and it may be that dot and cross diagrams don't take you too long, but actually this next method I'm going to talk about is going to help you with your dot and cross diagrams anyway if you don't already use this method. So we're going to apply it to these four molecules, and we're also going to apply it to another molecule, SO2, that comes up in these questions quite a lot. So the molecules we had were BF3, they were NH3, they were SO3, and they were CO2. Each of these very simple molecules just with one central atom and three atoms around it. I'm then going to look up the groups of each of these different atoms. So boron is in group 3, fluorine is in group 7, and there are 3 of them. Nitrogen is in group 5. Hydrogen we can say is basically in group 1. There are 3 of them. Sulfur is in group 6. Oxygen is also in group 6. There are 3 of them. Carbon is in group 4 and oxygen is in group 6, and there are 2 of them. And then we can just look at simply looking at the ones that go around the central atom. How many bonds are they going to make in total? So boron is in group 3, is going to make 3 bonds. Fluorine is in group 7, which means it's going to share 1 electron. Each fluorine will make 1 bond, and fluorine is also going to make, therefore, 3 bonds in total. What that means is there are no lone pairs in that molecule. Nitrogen is in group 5. It's going to make 3 bonds. and to each of the hydrogens. So there are going to be 3 bonds there, but that doesn't use all the electrons because there are 5 electrons, so there'll be 1 lone pair in nitrogen. What about sulfur trioxide? We could easily get this molecule wrong if we don't really think about it, because although sulfur and oxygen are both in group 6, they can't both be forming the same number of bonds. Oxygen, being in group 6, will form 2 bonds. So there's going to be 2 times 3, there's going to be basically 3 double bonds, so there will be 6 bonds. That means that sulfur is using all its electrons in that molecule. There will be no lone pairs. Each oxygen will form a double bond, and this is a classic example of a trigonal planar shape. So in fact it has exactly the same shape as our BF3, and although the bonds are polar, they're being cancelled out because they're all 120 degrees apart. CO2 is going to be a similar situation. There's going to be 2 lots of double bonds, so there's 4 bonds, and that means that there are no lone pairs because carbon is using all of its electrons in bonding. And in fact, 99 times out of 100, unless you're doing a weird sort of mechanism question, carbon will always be sharing all of its electrons and will not have a lone pair around it. How could we apply that to something that was not in the question? So all 3 of these are non-polar because all of those electronegative atoms, the oxygens or the fluorines, are equally spaced, equal distance apart and equal angles apart, so there is no overall dipole. Nitrogen, however, has a shape where the hydrogen atoms on the ammonia are all on one side of the molecule, so overall there is a delta plus around these hydrogens and a delta minus at the nitrogen end. Applying that to something that wasn't in the question, what about SO2? Well, SO2, oxygen's going to do the same thing it does in CO2. So the oxygen is going to make 2 double bonds. That means that I've used 4 electrons in the bonding, which means the sulfur has 2 left. So it has a lone pair. And SO2 is a polar molecule. And that comes up a lot when we're comparing SO2 with SO3 or comparing SO2 with CO2, because CO2 is linear, but SO2 is non-linear. So I've hardly touched anything about shapes of molecules, dipoles, intermolecular forces. There are quite a few more videos and some practiced questions and explainer videos, and all of the questions have got video answers that go with them on my website. And of course, if you can follow me on Instagram and Facebook for more A-level chemistry tips and revision materials that will be coming soon.